Okay, so we're going to do a basic drug dosage calculation problem. This is a drug dosage calculation based on the weight of the patient. And you'll see our problem starts with the weight of the patient as 26 pounds. The dose that we want to give is cefadroxil, that's the drug. And what we want to do is give it out at a rate of 22 milligrams per kilogram. So what that means is give 22 milligrams of drug for every 1 kilogram of patient weight. So that's what we mean by a drug dosage by the weight of the patient. The amount of the drug is directly related to how much the patient weighs. Now you'll notice in this case, the weight of the patient in terms of units of measurement that are given does not match the units of measurement in the dose. Right now, this patient weight is in pounds, but what we are doing is giving a dose based on kilograms. So that's not a match. So one of the first things we're going to have to do to solve the problem is change the patient weight from pounds to kilograms so we can use the dose information. The last piece of information here is the drug supply. So this is a 5% solution, and you're going to need to interpret that in order to do the calculation. So 5% in terms of this concentration information means that there are 5 grams of drug in every 100 milliliters of solution. It's probably no surprise that the denominator is 100 since we're dealing with a percentage. So 5 grams of drug in every 100 milliliters of solution. But we're giving out a relatively small amount. Right? We're giving out only 22 milligrams for every 1 kilogram. So we want to convert this drug concentration information into a much friendlier form. And the usual one that we'd go for is how many let's try that again, how many milligrams in 1 milliliter. So we would like to change this into some number of milligrams per a single milliliter. The way to do that is very simple. What we're going to do is take the number in the percentage, the 5, and multiply it by 10. And we're going to see that 5% is the same as 50 milligrams in 1 milliliter. And that's the trick, if you want to call it that. When you see the percent concentration, in order to change into the number of milligrams in 1 milliliter, take the value in the percentage and multiply by 10. So as another example, if you had a 40% concentration, that would mean 400 milligrams in 1 milliliter, because 40 times 10 gives you 400. So let's see why this works. So as we said before, a 5% concentration means 5 grams in 100 milliliters. And I want to prove that this is going to come out to be the 50 milligrams in 1 milliliter, right? Like I said before, we're going to get this answer. Now, you don't have to do this computation every single time. You can stick to the trick of taking the percent value and just multiplying by 10. But let's just see why this works. So right now I'm in grams per 100 milliliters. What I want to do is get out of grams in my numerator and get into milligrams. So I need to multiply by a conversion ratio that connects grams to milligrams. And I know that there are 1,000 milligrams for every 1 gram. So those cancel. And what I get in my numerator is 5,000. What I have in my denominator is 100. And I'm now in milligrams over milliliters. And when you do the division, 5,000 divided by 100, it comes out to be 50 milligrams for every 1 milliliter. So that's how it works. So if you have, say, a 2.25% concentration, multiply the 2.25 by 10, and that's 22.5, and that's how many milligrams per milliliter you would have. So just remember to multiply by 10. That gives you milligrams in 1 milliliter. So let's go back to the original problem. So the weight of the patient, again, was 26 pounds. The dose was 22 milligrams per kilogram. And the supply was a 5% concentration. Let's try that again. Was a 5, that's better, concentration, which we said is 50 milligrams in every 1 milliliter. So this is how it's going to go. The first thing we want to do is get out of the units that we have for the weight of the patient and into the units that we want. So I need the weight of the patient in kilograms, which means I need to convert out of pounds, putting pounds in my denominator, and into kilograms. And I know from my conversion sheet that 1 kilogram is 2.2 pounds. So if I were to stop here, this would just give me the weight of the patient in kilograms. But I'm going to do all of this out in one big cancel out technique. So my next step here, now that I'm in kilograms, is to multiply by the dose information. I know that there are 22 milligrams of drug to give for every 1 kilogram of body weight. So right now what I have, this changes the weight of the patient into the units of measurement that I need. Now, if this were 22 milligrams per pound instead of per kilogram, I would not need this first step because I'd already be in pounds. But since I need my patient weight to be in kilograms, that's what step number 1 is for. This next step is going to determine the weight of the drug to give. So if I were to stop here at this point, I would know how many milligrams of drug to give to the patient. But since this is a liquid drug, right, it's some number of milligrams in milliliters, what I want to be in at the final answer is milliliters. So the last step I need is to change out of milligrams and into milliliters. Right, if we're following the cancellations, we've canceled pounds to change the patient weight. We've canceled kilograms to get to milligrams to determine how much drug we need to give in milligram form. Now the last thing I want to do is use the concentration. I know 1 milliliter contains 50 milligrams of the drug. That will get rid of the milligrams, and I will be left with milliliters, and that's the form of the final answer. So this last step gives me the volume of drug to give. So step 1 changes the patient weight. Step 2 determines the weight of drug to give in milligrams. And step 3 determines the volume of the drug to give in milliliters. So we'll go one more page, write this out again, and come up with the final calculation. So 26 pounds, 1 kilogram is 2.2 pounds. We want to give 22 milligrams for every 1 kilogram of patient weight. And I know 1 milliliter of the drug contains, or 1 milliliter of solution contains 50 milligrams of the drug. So now what do I have in my final answer? Goodbye pounds, goodbye kilograms, goodbye milligrams. So I've got a factor of 26, and I've got a factor of 22, and in the denominator I have a factor of 2.2, and I have a factor of 50, and that's going to be milliliters. So when all is said and done, and we do out the calculations, 26 times 22 gives me 572. 2.2 times 50 gives me 110 milliliters. And if I take 572 and divide it by 110, I get a grand total of 5.2 milliliters to give to the patient. should make the patient feel better.